How's everyone doing this morning? Doing okay? All right. So my name's Doug Barth. This is my Twitter handle. If you guys want to follow me, you get to see funny tweets like this. Mostly just my kids making fun of me every day. I work at PagerDuty currently, but that's not what I started out as. I actually started my career as a developer, working at Orbitz, so doing back-end development and front-end development. I went to a startup after that, did development work, both front-end and back-end, and operations work like you would do at a startup that has 2 engineers. Learned a lot at that company, and then got the opportunity to come to PagerDuty and focus full-time on ops. And I've been there for about 2 years now. Started when the company was about 20 people. Now we're about 150. So I've seen a lot of change in the company's employment, or the people that work there, but also in the systems that we run and how we approach failure. Just a quick show of hands. Who here actually uses PagerDuty? All right, who here is actually on call? That's not cool. All right, so there are a few people that don't use PagerDuty. So for those people who don't use it, PagerDuty is an operations performance platform, and so that's just a fancy marketing way of saying that we make tools to help you manage your production incidents. The primary way that we do that is by integrating with all your existing tools, your monitoring tools, your chat tools, your ticketing tools, and give you a centralized dashboard for all of the open incidents that are affecting your business right now. When an incident is opened, it gets assigned to the current on-call engineer, which we maintain the schedule for that. And then that engineer is notified via whatever contact mechanism is best for them. So for me, it's an email after, or the minute it gets opened, and then a minute later, give me a phone call and just keep calling me until I respond. And so engineers are expected to actively respond to say that they acknowledge that incident, they're working on it. If they don't, then we go to the secondary engineer, or maybe their boss, their CTO. We will find someone to wake up and work on that issue. And so since we sit between you and your monitoring systems, reliability is something that we think a lot about every single day, and it's something that we plan for and try to build systems that can withstand it. And so that's what this talk is about, is how do we approach reliability in our systems, how do we try to make them highly available, and how do we try to handle disaster scenarios. So hopefully that sounds good. So let's talk about what we're actually or I'll give you an agenda of how we're gonna work through these topics. So first thing I wanna talk about is disaster recovery versus high availability. Kind of, in my mind, these are kind of 2 different ends of the spectrum in terms of reliability, and so we'll talk about what makes something a highly available scenario, what makes it a disaster recovery scenario. And then we'll get into a few more particulars. So data disaster recovery is often kind of overlooked and can be just as disastrous as losing a data center. So we'll talk about some of the key things you need in your data stores to actually recover from disasters. And then we'll get into the topic that you probably think of when we say disaster recovery, which is we've lost a data center. How do we recover from that? And the most common way we do it is using failover. But then we'll talk about why PagerDuty in particular doesn't really like failover as a disaster recovery system, and instead we try to strive for active-active systems as much as possible. There are some trade-offs with doing that, but we'll get into that. And then, of course, there's the ideal of what we want, which is active-active everywhere, but often we have legacy systems that simply can't support it. So how can we still support this failover architecture, but maybe take some of the lessons that we have from active-active systems to give us a more reliable disaster recovery system? And at the end, I have a lot of time for Q&A, so please feel free to hold your questions till then, and then we can go over them. All right, so disaster recovery. What do we think about when we're talking about disaster recovery? This might be really basic for people in the room, but disaster recovery in my mind is a plan for surviving rare failure events that threaten our ability to continue operating. And I like to contrast that against high availability, which is very similar too, right? Trying to withstand failure events in our system. So I made this very simple chart. Disaster recovery is rare. High availability is usually common failure events, things like losing a server, losing a disk, being partitioned away from the network. Those are all things that we expect to happen in a sufficiently large system, so we should plan for it. And then the other aspect that really that distinguishes these 2 systems is on a disaster recovery plan. Usually we accept that since these failures are rare, we're going to allow for a slower recovery time, whereas with high availability systems, we want extremely fast recovery time. Ideally, it would be no recovery time, right? If you have a multi-master system, That gives you a highly available service, but you don't have to have really any recovery time. So really the key thing that keeps us from having a disaster recovery plan be the same thing as a high availability plan is latency. It's the driving force that really controls whether or not you consider this a disaster or a highly available concern. And so when you're building your systems, you need to think about where is latency existing in your systems and how do you actually manage that as you do work and also as your user experiences your service. But whether you're on the high availability side or disaster recovery side, you do need a disaster recovery system. It needs to exist both in a documented procedure for how to use it, but also in a system that actually is stood up and is made available and you actually use it. And it's more important that it's very important that you don't just have it existing, but also that you have some plan for testing it. And I like to break down the testing of a disaster recovery system along kind of 3 axes. So first thing is when you're testing your disaster recovery system, you need to have some plan for testing for correctness of that system. And when I say correctness, I mean that all the server roles that you expect to live in that disaster recovery environment actually are there, but also that any configuration is correct in that disaster recovery environment. It's very easy for the system that sits to the side that you only use in those rare events to fall out of sync with production. So we need to have some plan for testing for correctness. But we also need to have some plan for testing for capacity, right? If we're going to flip to this disaster recovery environment, we need to make sure that it has at least production capacity, and some could argue it maybe even needs more than production capacity because when you switch to that environment, you're going to be putting production workload on a system that doesn't have warm caches. It needs to work through a backlog, and maybe it's processing traffic that is higher than normal, and that's actually what caused your disaster. So we need to have some thought about how we test for capacity. And then last thing is we obviously need to have some plan for testing our ability to execute this change in system configuration, because usually it is a production system, and then we reconfigure to a disaster site. So before we get into kind of the data center changes, let's talk about data disaster recovery, because I think that that's something that we don't want to miss in our discussion. So when I'm talking about data disaster recovery, I'm saying you have a database like MySQL or Postgres, or maybe you have a data store like S3. But either way, you have all this data that's extremely critical to your system, and if something were to happen to that data, that could be a disaster in and of itself. So you can never have too many copies of this data, and you need different copies that are serving different purposes. So let's start with the basics, right? We lose a disk, we lose a server. What are we going to do? It's really an HA concern, but for some companies, that may actually be a disaster scenario. The most common way to do that is obviously you have a secondary. That secondary is replicating changes from your primary data store. And there's a few different options you can do here. If you're in a low latency environment, say you're within a single data center, you might look at something like DRBD, which is a block block replication framework for saying that I have these 2 servers, they are connected via the network. I want to write to the primary server and have it be on the secondary server, right? And then you get a synchronous copy of your data. If latency is a lot higher and you can't withstand that, oftentimes you'll have a disaster recovery site where you have replication, an async replication from your primary data center to your secondary data center, and that's how you keep a second copy of your data around. And for some people, that may be all they do in disaster recovery, but that doesn't really cover all the disastrous scenarios you can have. What happens if we have data corruption? We could have it be some bug in our OS, but maybe it's just a bug in our application. It's been silently changing data on us for a few days. Backups, right? It's all very basic stuff, but we need to make sure that we understand the systems that we need in place. So we need backups. They need to be restorable, so we need some plan for actually testing restoration. The way that we handle that at PagerDuty is we actually set up a pipeline of restoring our backups to test environments on a weekly basis, and that gives us a lot of confidence that the ability for us to restore a backup is something that we could do in a disaster scenario. So our load test environment receives a weekly restoration of our production data set, which is then sanitized so that we don't have any sensitive data and don't leak customer info. And just having that automated process really helps with making sure that our systems work. And then there's the third type of disaster that's the worst thing in the world. What happens if someone is doing maintenance, they drop a critical table, or they delete too much data? What do we do then? And so the way to solve that problem is we can have secondaries that are replicating changes immediately from production, but a lot of database systems allow for delayed replication. So we use MySQL for our relational databases. Percona has a tool called PT slave delay, where we purposely tell this slave to lag from production by a few hours. And so instead of having the disaster recovery procedure be restore from backup, which takes 5 hours, now we have a system that's lagging 2 hours behind. We can let it run up to the point of that very bad command and then skip over it, right? And then continue on from that point. So it really shortens the window that we need to recover from backups. And that's probably something you should look for in your databases or in your data stores, just some way to really speed up recovery. So that's all probably very simple. Let's get into the meat of it. And that's, we've lost a data center and we need to fail over to some other system. So that's, we usually have a primary data center and a secondary data center. In PagerDuty's case, we run all of our systems on cloud providers. So when I talk about like primary and secondary data centers, I'm not really referring to physical hardware that we're managing. It's actually more abstract, right? It's just our service runs here. Now we need it to run there. And so the common way that we do it is we have a failover, and then we have this. We have the flip, right? The thing that we need to do that is very rare, it's very time consuming, and usually testing it equals outage. We're not gonna be able to usually hide the flip from customers. Maybe we can script it and try to speed it up. But either way we do it, it's gonna entail an outage. It's gonna be visible to customers. So unfortunately, it often goes untested, simply because we have enough outages as is. We don't want to add yet another one that's planned, and that makes me sad. I feel like this guy, right? We don't want to have an unplanned or a system that we don't test. So we'll test it, but we'll test it infrequently. And I still see that as it's a better step towards having a disaster plan, but it's still kind of not very great. And why do I not think it's very great? It's because if we do these flip tests on a regular basis, say we do it every 3 months or every 6 months, that's great. We'll figure out if things are going to work in that flip test. But almost invariably between every single flip test, some breaking change is going to slip into that system. And then this time between that breaking change being inserted and the next flip test, that's the window of time where if we were to flip to this disaster site, we will find that nothing works. And it doesn't actually help us if we have a system that we're paying a lot of money for, and once we flip to it, we find that things are broken. And they will always be broken if it's this infrequent test. So we need some way to validate correctness that's not just scheduled and infrequently done. It needs to be continuous. And so we'll talk about how we try to approach that in our systems. And then there's other little things that can hide there. Maybe we do these flip tests. We validate that the main portion of the system is working as expected. But sometimes there's going to be these side systems that aren't really like extremely visible and in the critical path of the system, but they might be extremely important if we do the flip. Say, for example, we have a system that's responsible for letting users sign up for new accounts. Well, we can't make money in the disaster recovery site if we're missing that role. But it's probably not going to be center of our mind when we're doing this high-stress flip test. So these types of roles can just linger and not show up in the disaster recovery site. And once we do the flip, now we're not only struggling to get the system up and running, but we're also struggling to stand up more infrastructure to fill out the gaps that we didn't notice because we did this very manual and easily messed up process. We can also find that when we need these disaster sites during the middle of the day, maybe we're low capacity. I would imagine most people that do a flip test, right, are going to do it during a trough of traffic on their system. So it's on the weekend, probably in the middle of the night, and they're understandably doing it so that they can minimize the impact to their customers, because we said there would be an outage when we take this or do this flip test. but that doesn't really help us validate that we have enough capacity to withstand Monday morning's traffic. So we need some better ways to actually validate that the capacity in our disaster recovery site equals production. And so all of these problems we have with our disaster recovery site that uses failover, to just top it all off, it's very expensive, right? We're gonna have this system where we probably have an exact copy of production, and when we go to flip to it, we're gonna find problems with it, we're gonna find low capacity, and great, we just spent a ton of money on a system that doesn't even work in the rare scenario where we actually need it to work. So this is kind of why we get to active-active. So PagerDuty, I think it's not unfair to say we really like active-active. We potentially even love it with a green heart. So our systems, our new systems that we are designing for disaster exist in multiple regions. So we use US West 1, US West 2, and Linode, so 3 different public cloud providers. And we deploy our application across all of those regions. And each one of them is receiving active traffic constantly. I also like to call out that Amazon in particular gives us these availability zones, which they tell us we should treat as individual data centers. And our own experience has been that that may be true from a power and local LAN perspective, but from a wider internet connectivity, that actually is not the case. We often see correlated failures across AZs within their regions. So when it comes to deploying our application, we deploy it across all of the availability zones within that region. We don't really give even a second thought to how traffic is being routed between those AZs. It's just completely load balanced, and that gives us some redundancy, but it's really not enough. We need those multiple regions to withstand failure. So this is a very complicated picture, but I wanted to give you guys an idea of how do we handle that multiple region deployment. And so for a lot of our backend services, what we use is Cassandra as our data store, and then Zookeeper as a coordination service. And we basically just run a cluster between all 3 regions. And then there's app deployments in each region. And again, they're all receiving active traffic. They're each taking a third of the work. And that's how our systems work, right? If you've used Cassandra or Zookeeper, these are quorum-based data stores. So built into the system is the ability for us to lose, in this case, 2 servers out of 5 before we lose quorum. And that's how we're able to make sure that we can withstand a single data center loss. So things we like about this setup. One is, obviously, it's constant validation, right? It's receiving production traffic. So we have a high degree of confidence that if we were to lose a data center, the other 2 data centers will continue to function as they were before. But we don't just assume that it will continue to work. We actually test it. So every Friday, we do a process we call Failure Friday. We've written a blog post about it. I've given a talk previously about it. This is basically our manual, bare bones way of doing what Netflix does with their chaos army setup, right? We just go get in a room, operations and development teams, and we go service by service, and we shut off data centers on a regular basis and watch and make sure that it does what we expect it to do. And we shut it off in a few different ways. So we'll do stopping processes. We will misconfigure firewalls to do network isolation. We'll even add latency at the interface level so that we can just make sure that this system will route around failures and continue to work. But in everything, there's always a trade-off. And really the thing that we are trading off and needs to be said, right, is we're trading latency, the just ability to process a single bit of work quickly, for reliability. For us, that is a trade-off that we can make because the core of our service is hidden away from users. So it's receiving events from monitoring systems and actually calling them. If that's a second slower, they're not necessarily going to notice that second because they're not sitting around waiting for the page to go out. But it is something we keep in mind. So this is a number that I always have on the top of my head. 30 milliseconds of round trip time is the time between our 2 regions. That also kind of factors into which data centers we can use. That's why most of our data centers are on the West Coast, is because we need a reasonable amount of round trip time. But even still, that's not a very reasonable round trip time if you were doing something that's user dependent, right? That they're sitting there waiting for a response. But things are not always the way we want them to be, right? We do have legacy systems. PagerDuty at this point it's about 5 years old, and there are still systems, sadly, that use failover for their disaster recovery scenario. So a project that I recently did at PagerDuty was rebuilding our disaster recovery site. Because it had all those problems that we talked about, it was languishing and in not being tested and missing roles and being under capacity. And we wanted to rebuild that disaster recovery system so that it actually serves the purpose we want it to. So that's where we get back to this. What do we need to test for? What are we looking for in a disaster recovery site? It's correctness, it's capacity, and it's our ability to execute. And when I approached that problem, we had our old way, right? It was the site that you could flip to, and that would be how you made sure it worked. And I didn't want that again, so what we did instead was let's break down this problem. Instead of trying to tackle all of these testing or all of these characteristics we need to test for in a very invasive flip test, let's figure out ways that we can actually just break it down and attack each piece individually. So let's start with correctness. We want to make sure that this site is production worthy, that configurations are correct, that if we were to change all of our production traffic over to the disaster recovery site right now, that traffic would flow through it. So the way that we do it is we actually send 1% of our production traffic through our notification pipeline to the DR site. This is a great way to find issues immediately, because if we have a misconfiguration in some backend configuration file, it's going to blow up. We're going to find out about it immediately, right? But that does mean that we are going to need a read-writable database, and so for us, that ends up meaning that this DR site that is in West 1 actually uses the production database in West 2, which incurs a round-trip call, right? So now we have 30 milliseconds per database call. It's obviously a very slow site, right? But we are trading latency to test correctness, and since this latency impact is completely decoupled from users actually sitting in front of the site, it's a trade-off that we can, in fact, make. So if you wanted to do something like this, I would say that you basically need to figure out how can you still give a reasonably responsive experience to your users while hiding the latency from them. In our case, it's maybe a production request takes 100 milliseconds. In the DR site, it takes a second. If you can hide that latency from users, then I would say that trading off the impact in latency for a small percentage of your users is better than having every request be fast and a disaster recovery site that you can't trust when you do the flip. I guess one slide I didn't throw in here is how do we actually execute this peel off of traffic? So the way that we do it is we have HA proxies sitting between the client and the server, or the service itself. So we have HA proxy just have two backends that we weight the DR backend at 1% of traffic and the production backend at 99% of traffic. So it really ends up being that all 1% of connections go to the service, to the DR service instead of the production service. So that's one area that we test for and we work on. The next thing is we need to think about capacity, right? We're only sending 1% of traffic through this DR site. That's not going to help us validate capacity. And so what we want is, we really want disaster recovery to be a complete mirror of production. Since we want to be able to recover as quickly as possible, we just spend the money and make a second copy of our production environment. And the way we validate that DR is actually a complete copy of production is we leverage our our configuration management system to just compare those two environments. So we have a very simple script, just goes over the chef environment for production, looks at all of the servers that are running in our production environment, what role do they serve in the production environment, and validates that DR has a one-to-one copy of production. It's made a little bit easier for us because since our disaster recovery site exists in another EC2 region, we can just compare servers by instance type, right? So we can say that we have 20 of this role, they are this instance size in production, therefore we should have 20 of this same role and the same size in disaster recovery. If you're using different server or service providers, and therefore you don't have that kind of direct way to compare instance sizes, your job is made a little bit more difficult. but it's still a valid way to do it, right? To be able to say that this server is greater than that server, and therefore do we have in aggregate the same amount of capacity in disaster recovery. So this is just a script that runs regularly and will page out to us if there's any difference between disaster recovery and production. And so that'll help make sure that capacity in the two environments is consistent. But it also serves a nice little extra benefit, which is that it's going to surface those missing roles that we can have sit in our disaster recovery environment. So the way that we set up this script is that any role that comes into the production environment is by default assumed to exist in the disaster recovery environment. And you have to proactively go and mark roles as being excluded from disaster recovery. So what are some roles that we might be willing to exclude from disaster recovery? It could be something like a backup host for the production database, potentially. Even that could be argued as maybe we don't want to do that, or maybe it's that those delayed slaves. It's just kind of roles that we figure that once we flip to the disaster recovery site, we're going to flip back as soon as possible. And then we have the last thing we need to test for, which is obviously our ability to execute this change. And that brings us back to that flip, right? But what we don't want to do, or at least I don't want to have impact customers, is I don't want that production impact. And so the way that we handle that is, given that we have a system that's validating correctness of our service by sending a portion of traffic to the disaster recovery site, and we have monitoring in place to ensure capacity and missing roles actually exist in the production site, my argument is that do we really need to test that in production? And so what we do instead is we use our staging environment where we have a copy of production. We have systems that can drive load to the staging environment and validate its correctness. So we can use that as an environment to actually test the flip, right? So we can have a staging environment, we stand up a staging DR environment, and then we can go and practice the flip there. It's a good way to hide that testing from customers, to validate more frequently that our flip procedures are correct, but without incurring production impact. But there's still some downsides to this. This is probably the thing I like least about our disaster recovery setup, is that no matter how much testing we want to do, it's still going to be tested infrequently. We're still going to open ourselves up to that failure window where changes that we didn't think would break disaster recovery exist in the environment. And if we were to flip production to the disaster recovery environment, we might find that it's broken. So that kind of brings us back to why we like active-active, right? We can do these tests frequently, we're getting constant validation for capacity, and the configuration changes in the system are very minimal. It's just lop off a data center instead of I need to go change a database configuration file and repoint providers to another system, and just on and on and on. All this reconfiguration that's error prone just kind of goes away, right? So new systems that are coming online, again, they're active-active. And the plan is that the systems that are still a failover architecture will move and progress towards an active-active setup. So kind of rounding up, these three things, again, when you're setting up disaster recovery, think of ways that you can validate for correctness, ensure you have capacity, and are able to execute these flips. So that's all I have. PagerDuty is hiring. If you guys want to come and help me build a reliable system, you can check out what jobs we have available. You can also email me. I'd love to explain to you why working at PagerDuty is a great experience. And now I have plenty of time for questions.
Microphone's on in the aisle, so whoever wants to ask a question.
Any questions? Nope.
Does PagerDuty use PagerDuty?
Okay, so the question was, does PagerDuty use PagerDuty? So the answer to that is thankfully yes, but our monitoring is split into two pieces. So low-level incidents, things like one server having high load, is looped back through PagerDuty, and we use it to manage our own on-call schedules. Anything that's extremely severe, where that notification pipeline is impacted, that's where we use other systems that are not dependent on PagerDuty to basically call every engineer in the company and get them working on the issue. I have plans or hopes that at some point we can get enough people to come work at PagerDuty that we could have a PagerDuty, the production site, and then PagerDuty, the employee-only system, and do like kind of cross alerting. So any issue in the PagerDuty employee-only system would page through production and vice versa. But that's kind of like, I need someone to come help me build that. So if you want to help me build that, that'd be awesome. Is there any other questions? All right, I guess not. Well, thank you guys.